Welcome to my general problems mechanics walkthrough. Today we're going to be looking at the pressure and density at the bottom of the Marianas Trench. So let's have a look at the question. The depth of water in one of the deepest parts of the Marianas Trench is 10.9 kilometers. Assuming that seawater, which has a density of 100 kilograms per meter cube, is incompressible, calculate the pressure at the seabed. Let's have a little very simple diagram. Here's our Marianas Trench. It is 10.9 kilometers deep, and the equation for pressure is simply rho GH, where rho is the density, G is the acceleration, and H is the depth. And we can put in our values as such, and we get a value of 1.07 times 10 to the 8 pascals. Now let's have a look at the second part of the question. In reality, seawater is slightly compressible, having a compressibility of 45.8 times 10 to the minus 11. Estimate the density of seawater at the bottom of the trench. So, the equation that we're going to be looking at is an equation for the bulk modulus of a material, where it says the total bulk modulus is minus change in pressure times by the initial volume divided by the change in volume. So we can rearrange this very simply to get our change in volume on the left-hand side of the equation. And we know that the bulk constant is 1 over the compressibility. So we can sub this into the equation to get our change in volume is minus our change in pressure times by our initial volume times by our compressibility. And if we sub in our values, our change in pressure is the 1.07 times 10 to the 8 pascals that we got before. We get a change in volume of 0.049 meters cubed. Now, the volume at the bottom of the Marianas Trench is the same as the volume at the top, plus the change in the volume. So 1 minus 0.049. And so we can find our density, which is simply rho equals mass times volume. Our mass is still 100 kilograms because that's the density of seawater, but it is now in a volume slightly smaller than what it would be at the surface, and that slightly bit smaller is 0.049, and we get our answer of 1051.5 kilograms per meter cubed. Thank you very much for watching. If there are any steps that you didn't understand or any steps that I've gotten wrong, please do let me know down in the comments. Thank you very much.